Welcome to ePathshala lecture series in computer science, and this is a course in cloud computing. Today we will discuss about the peer-to-peer networking and its use in cloud. Let us first, before we get into the actual content of today's class, let us look at the what we already know about the client and server architecture. And from this discussion we will identify why client server is not sufficient and why we need to go for some other architecture. So, client server is a centralized architecture that we already are aware of. There is a single server. In a specific setup there is one server. We can have multiple servers also, but each server serving a set of clients. So, we assume that the architecture promotes a single server environment, and these server will be serving requests from multiple clients. So, there will be so many clients which will be connected to the server, and the server will serving the request. So, when the request comes from a client, the server finds the answer to that request from its data, and it replies to the client. Now, if we look at this architecture of client and server request and reply, the benefits are very easy management. We just put one server, we configure a server, and we can let that IP address be known to all the other machines which are clients, and there quickly we can deploy such a system. Now, what are the drawbacks of this system? Are that this is a single point of failure. What do we mean by single point of failure? As we have discussed at length during our distributed systems course, that if the server fails, then there is no service that can be given to the clients. So, the clients have to wait for the server to come back up before they can continue with whatever is there. That is one problem. The other problem is that it creates a huge bottleneck in and around that server, and therefore, it generates a bad traffic congestion near the server, which is a very busy server, and therefore, causes problem for everybody all around. So, this bottleneck and single point of failure are the major problems which actually has made people to look for some other architecture which is not a centralized architecture, and from that the peer-to-peer architecture or P2P architecture has developed. So, this is a distributed architecture. We have looked at distributed systems, but this is a truly distributed architecture where just like clients in a client server, there are many systems in this architecture, but the difference is that each node will act as a server, and the same node can also act as a client depending on what this node wants or what this node has to offer as service. It can act either as a client or as a server. So, how do they communicate? They will coordinate among themselves. There are various methods that have been developed to have this coordination. They will coordinate among themselves, and they will make sure that the data is available. So, there is no dedicated connection between these nodes. And most important part of having a P2P service is that the number of the nodes is dynamic. Now, if we compare a P2P server with our client server, we see that first and foremost is that client server is a managed environment, whereas a P2P server is a self-organized environment. What we mean by this is that the client server will be a configured environment and it will be predefined, but in a P2P nodes can dynamically come and go. Same reason why we say that client server is a configured environment and P2P is an ad hoc environment. In client server, clients do a lookup for a server. So, we can have specific mechanisms like a domain name server, and we can have a lookup for a server. But in peer to peer, there is it is very difficult to maintain a DNS server in peer to peer environment. So, one peer has to discover the other peer. Obviously, client server is a hierarchical, and this is a mesh, a flat structure with mesh. Client server is static in the sense that we give an IP address to the client and to a server, and the server has to be present at that specific IP address. So, it is a static. So, I cannot dynamically add server on the fly, whereas in P2P it is possible to add new nodes. The dependencies on the server, here it is the independent. Each peer has their own lifetime, and the total network will not depend on any specific node. Therefore, in client server, the IP address of the server becomes of prime most importance, but in peer to peer no such requirement is there for any specific node. Client server, as we have mentioned already, is DNS based, that its discovery, that we say its lookup is DNS based, whereas the names of the peers are independent of that. And last but not the least is the communication mechanism between in a client server is typically RPC, RMI, as we have seen, but in a P2P it will have to be an asynchronous, because for obvious reason we cannot expect that one node will, all the nodes will wait for one specific node to complete its work. So, how does it work in a peer-to-peer environment? There will be thousands of peer nodes. These will be connected using the underlying network. So, to imagine that I have to deploy an application in such a huge environment is rather a daunting work, and to make a little easier, what we do have is a logical network called a overlay network. Let us see how this overlay network works. It is a logical network. This is built on top of the physical network. So, in the underlying physical network there will be nodes, but the logical network will go in. Now, the nodes are the subset. So, some of the nodes that I take from this logical network, physical network, I will create a logical network, and this is the subset. I can create from one physical network, I can create multiple such overlays, each corresponding to a specific application that I may be having. Now, if there is one physical node, we consider this particular node, it is quite possible that it will be part of two such overlay, or more than two. If there are 20 overlays, one node can be part of all of them or a subset of them. There is no restriction that a node will be part of only so many overlay network. Each overlay is a specific application. So, if I have to say deploy 3 or 4 different applications in a P2P network, I select a set of physical nodes and I represent them in a logical environment. I use their physical connections to somehow represent the connection in the logical network, and I call this my application environment. Therefore, the whole environment being so complex and vast does not really affect the application environment of the setup. So, here this works like this. This is my physical network, which is consists of the routers and the switches and all the networking components along with the nodes. Now, when I want to have an overlay with a subset of them, I represent them in the logical world. Each of these nodes, whichever nodes I want in my overlay, I create project their images in the logical space, and then I create a virtual link among them. We know that through routers in the physical network, it is quite possible to connect any node to another node. So, therefore, any type of virtual links we are free to create, because in the physical network we can always get the help of the protocols, and this consists of my one overlay network. Similarly, we can create another overlay with another subset of nodes. Now, so the whole of workings of P2P network depends on how we handle the overlay. In the physical layer, whatever is happening, how that is projected to the logical layer is the main purpose of having to study a P2P. So, basically we classify them in two broad classes. One is called the structured overlay and the other is called the unstructured overlay. In structured overlay, we have a fixed topology. So, we predefine the topology, we define how these nodes are connected, logically connected to each other, and we set specific routing mechanism, all in the logical network, not in the physical network, but in the logical network we predefine the routing mechanism, and we set specific rules using which nodes can be added or deleted. One thing we must remember, that it is still a dynamic network, which means that even when it is structured, we have to ensure that nodes are allowed to join in and nodes are allowed to leave the network. In unstructured, on the other hand, it is more of a random graph kind of a structure. So, as we know that graph, there is no hierarchy, no specific structure. A node can be accessed from any other node in multiple ways. So, there is no fixed route to send messages. I can in the best effort basis I can send a message. So, one typical way, there are other ways, we will discuss about that, but one typical way of sending a message would be flooding, sending to all nodes possible, and the particular node that is responsible or that is supposed to take the message will get back in the flooding mechanism. So, the resources will be placed anywhere. Now, in a P2P, the important part to understand here is that resources are data, and these data will be stored in the underlying network, in the underlying machines, in the physical machines in the physical network. When we talk about the overlay, the whole discussion or our point of learning is how do I store the data in the physical network, so that I can easily discover where my specific data is. So, the shared resource, which are the data which has to be shared among the peer nodes, will be placed in any one of the nodes in an unstructured, whereas this is not the case in structured, because in structured we specify this is where specific node has to be and this is where the data has to be placed. So, let us look at the structured P2P. It is a dedicated network, and the discovery of resources happens using a few mechanisms, of which distributed hash table is the most popular mechanism. This is called DHT, or distributed hash table. In this distributed hash table, there have been many setups, many mechanisms that have been developed using DHT. We will keep our discussion in this a generic discussion, but students can look up various specific mechanisms that have used DHT to build a P2P system. But in a generic DHT, each file will be associated with a key. So, whatever I want to store, I will be generating a key for that file, and this generating mechanism is a hashing mechanism. So, I will use hashing to generate a specific key for a specific file, a unique key for a file, and I have the large range of keys, and I divide these large range of keys among all the participating nodes. So, each node will be in a predefined manner even before the data is stored. The number of keys will be assigned to the participating nodes. So, in a structure it is very specific that I assign a set of keys to one particular node, set of another keys to another node, and so on and so forth. So, since the network is structured, so we have a specific routing mechanism, and the routing table will be maintained by the peer nodes. The APIs, the typical APIs are put and get. Put file will keep the file, store the file in a specific node, whereas get file will obtain the file from the node. So, it is called a consistent hashing, where consistently it assigns a random number to the nodes with respect to their which will act as a node ID. So, the identifier space has to be very large. The success of DHT is that in a large identifier space, nodes will be given some unique ID, and with respect to the unique ID, it is possible to assign a set of keys which corresponds to this large identifier space, and these keys will be distributed among the, or the responsibilities of the keys will be distributed among the peer nodes. So, if there is a 64-bit string, then we can have 2 to the power 64 keys. Similarly, if I increase the number of bits in the string, my number of key space increases. So, any file, video, audio, document, or any file will be mapped to a key, and the keys will be mapped to a unique peer. This way DHT will be storing the data. So, this key and comma data, that means a data mapped to a specific key will be there in one of the peers, and any specific hash function like SHA-1 can be used to find the node which has this particular key, and we use the put and get mechanisms to store and retrieve data from a DHT file. So, here is an example. This is our logical network which contains the data, and data 1 will hash and will store in a specific node. Similarly, data 2 will be hashed and stored in a specific node, and data 3 will be hashed in a stored in a specific node. Now, whether we should have different hash functions or the same hash function will depend on what kind of data object we are having. Same kind of data object, we can use the same hash function and obtain a unique value for that, and we can go for it. So, the point here is how do we control our nodes joining and leaving the distributed in a distributed hash table. So, the problem, as we know of hashing, is that the buckets are sequential, and to take one bucket out of this system in a traditional hashing method is requires all the buckets to be rearranged. This particular hashing method that is used in DHT does not require that. Let us see, when a new node, a new peer node joins, we have to do something. When a node leaves, maybe it is a meditated leaving the node. The node wants to go away knowingly. So, it can organize it, it can send messages, receive messages, and then lead, and unexpectedly also maybe a node suddenly gets shut down, that also it can happen. So, how P2P manages that is this: when we have a new peer node join, first of all we assign a new identifier for that node. So, say I have 10 this identifier space has 10 nodes, it's possible to have 10 nodes. I start this DHT with 3 nodes. I give the values to be maybe 1, 7 and 10. Now, when a new node joins, I hash its IP address or a specific part of the new node and get a value mapped to some number between 1 to 10 other than 1, 3 and 1, 7 and 10. So, we get that, and that the node represents that particular number in the logical network, and then what we do is we look at its siblings, its near neighbors. Since it's a logical ring, only 2 nodes will get affected by a node joining. So, if I have nodes in 1, 7 and 10, maybe if I add one node as 6, then only 1 and 7 will get affected because there are no other nodes in between. So, it takes some data from 7 and starts managing the data and those keys after that. So, the new peer node and all other affected peer nodes will be updating their routing table. So, the new peer node will have a routing table and the other peer nodes will be updating only the affected peer nodes, not all peer nodes will be affected. Now, what happens when a node leaves? As we can understand, this consistent hashing mechanism does what? It allows us to redistribute the keys without affecting the whole network. So, when a node wants to leave, it simply has to notify its neighbor about that that the node is leaving, and this neighbor will take care of the responsibilities that was there with the node that is leaving. So, if 7 now wants to leave, it will contact 10 and it will say that I would like to leave, and whatever key managements, once the keys it was managing will be transferred to the next node. What happens when there is no premeditated leaving? It suddenly fails, a node fails and leaves. So, no notification is possible. So, nobody is really aware that a node has failed. So, in that case, the failure has to be detected. So, when through the discovery mechanism, when one node discovers that this particular node is not responding, therefore, they conclude that the node has failed, then they will, once the failure is detected, same process as the premeditated node leaving mechanism can be used, and updation of the routing tables can happen. Now, let us look at the unstructured peer-to-peer. In unstructured, there is no fixed network structure, and therefore, it is much easier to make changes. I really do not need to update a specific node as we had to do it in a structured environment. So, there are a few search mechanisms that are used. One is called a blind search and the other is called an informed search. In blind search, the peer has no information about all other nodes. So, what it will do, the basic inherent mechanism, intuitively we can understand that the only way, it knows its neighbors. It knows a peer node is aware of who are its neighbors. So, it will send the query to all its neighbors. Each of these neighbors will send its query to all the other neighbors, and this mechanism is called flooding, and using flooding we can do. Unfortunately, flooding requires broadcasting by each node and it is very expensive. Instead of that, one cheaper mechanism is called random walk. In random walk, what we do is, instead of sending it to all nodes, the query is sent to one randomly chosen node, not knowing any information, but if I have 10 neighbors, I choose any one node and I blindly send my data to that particular node. That is a random walk, but as can be easily understood that the success rate of random walk will be much less than the success rate of flooding. But flooding will come at the cost of huge congestion in the network. On the other hand, in informed we can have the peers maintain some kind of additional information about other nodes. So, we can have some kind of topological information, we can maintain some statistical information about what the other node is storing, some kind of table which says that this particular node has so much of this, and we can also have a caching mechanism by which if a query has happened earlier on, the result is stored in the cache of a peer, and for the next search we first search the cache of the peer to see whether some relevant information is available. If it is not available, then we do some informed search about the node. Now, in unstructured we have a few types. One is called the centralized P2P, the next is called the decentralized P2P, and the third is a hybrid model. In centralized P2P, there is a server. Now, this server contains what? We must understand this very clearly. The server does not is not the same as in a client server mechanism server. This is a server which contains the indices of information about the data among the nodes. So, the data is still shared among so many peers. So, there is no server which contains the data, but this centralization is for storing the information about other nodes, which node contains what data. So, the indices of the nodes are stored, and we have the centralized servers. Napster and BitTorrent are examples of this. In decentralized, we have no such centralized mechanism. Each node can have a small piece of information, and accordingly they can do it. And in hybrid, we have the goodness of the decentralized and some good part of the centralized, and create a hybrid node. To summarize this module, we looked at what is a peer-to-peer architecture, and then we understood what is an overlay architecture in a peer-to-peer network, and we looked at different types of structured and unstructured overlay network. In the next class, we will look at how this structure, the different types of unstructured network, we will look at examples of that, and then we will come to the main point of why we are studying P2P in a cloud environment, how P2P is present in a cloud environment. These are the references. Thank you.